Hello, ladies and gentlemen. We are taking a look at the fall 2018, I'm sorry, not fall, spring 2018 final exam schedule. On May 23rd, you should have taken your Chapter 19 test. In class, you'll have 2 days to review for your final. You'll also have the 3-day weekend, and then your finals will be taken on May 29th, May 30th, and May 31st. I want to remind you that your final exam review is worth 10 bonus points on your final. That's something that you want to make sure you take advantage of. Also, please note that you'll need to start working on it on May 23rd. We should have passed it out in class that day, and you'll have plenty of time to get it done. All right, we're going to take a look. Any question on this that has a plus in front of it is something that will require you to use a graphing calculator. Your teacher will probably tell you to make sure you work those problems first in class, but just in case they didn't, I want to go ahead and share that information with you now. I'm going to start by taking a look at simplifying expressions. When I take a look at problem number 1, the first thing I notice is that 2 to the x is raised to the power of 0. Anything raised to the power of 0 becomes 1, so I can essentially ignore that and just know that I have x to the 4th, y to the negative 5th. Now, we don't want to keep a negative exponent, so what we're going to do is move that exponent because the negative exponent is telling us to move its location. So then I would have x to the 4th over y to the 5th, because if I move it, I'm going to drop it down to the denominator. There's nothing else that we can simplify, and that's our final answer for number 1. Taking a look at problem number 2, I'm going to look at it number by number, letter by letter. So I divide it out, literally putting space between everything. Start by taking a look at the numbers. 16 and 12, I asked myself what will divide into both of those. Well, 4 will go into 16 and 4 will go into 12. So 16 divided by 4 is 4. 12 divided by 4 is 3. So I've divided out a magic 1. Now when I take a look at my A values, I can remember that when I divide, I'm going to subtract. So I know that for my A's, it would be a to the 3 minus negative 2. Minus a negative is going to be plus, so it will be a to the 5th. So right now, my answer, I have 4/3 a to the 5th. Taking a look at my B values, I know that it's b to the 5 minus 6, which means that's going to be b to the negative 1. That negative 1 lets me know that I'm going to have to drop it to the denominator, so I have b to the 1st. Taking a look at C, I have c to the 12 minus 5. Wait, did that wrong? It's going to be c to the 12 minus a negative 5. That's going to end up becoming positive there. So negative 12 plus 5 is going to be c to the negative 7. So I know I'm going to put my c in the denominator. And this is our final answer. Taking a look at the next problem, problem number 3, again, number by number, letter by letter. So I'm going to put my numbers together. I'm going to put my exponents together, my same variables together. And I can do this because we're multiplying. If it were adding, that would be a different ballgame. So 3 times 5 is easy. That's 15. And then I take a look at this and I put that in my calculator. And in my calculator, I would say 3/4 plus 5/2, which is going to give me 13/4. So I have x to the 13/4. Taking a look at my y, I'm going to add those exponents. So it'd be 4/3 plus 5/6. And I end up with y to the 23rd 6. And that's it. Oh, number 4. Number by number, letter by letter. I'm going to use my highlighter on this one because this looks annoying. So I'm going to take a look at my numbers first. And 3 times negative 6 times negative 4 is going to be 72. So if I multiply all of these, then I end up with 72. Now I'm going to look at all my A values. So I have a to the negative 3 plus 2 plus 2. So negative 3, all I'm doing is adding the exponents. So negative 3 plus 2 would be negative 1, plus 2 more would be 1. So I know I have a to the 1. Now I'm going to look at all the b values. So b to the 4 plus negative 3 plus 6. Again, all I'm doing is adding those exponents. I end up with b to the 7th. If you don't know how to do this in your head, then you would just type it in your calculator. Finally, taking a look at my c's, that's a 1. I've got a 1 on this one. I've got a 4 on this one. And I've got a 2 on this one. So I end up with c to the 7th. You don't really need this 1 on the A. I only put it there just for fun, in case you need it. It's not wrong if you do, just know it doesn't have to be there. And that's our final answer for number 4. Taking a look at number 5, number by number, letter by letter, 5 times 4, and then n squared times n cubed. So I end up with 20 and n to the 5th, because all I'm doing is adding 2 plus 3. And so I get 20 n to the 5th. Now this next one is a power to a power model. So I have this exponent on the outside that I need to bring in. So I've got 6 cubed a to the 5th times 3. Because it's a power to the power, I'm going to multiply. So 6 cubed, when I put that in my calculator, you can either say 6 times 6 times 6 to get your answer, or you can do 6 caret 3, whichever one you wish to do. It works. But either way, when I put that in my calculator, I get 216. 5 times 3 is a to the 15th. Taking a look at number 7, I'm going to simplify number by number, letter by letter. Some people it helps to spread it out. All right, what we'll divide into 4 and 24? 4 goes into 4 once, and it goes into 24 6 times. So I know my answer has a 1/6. If I look at 7 and 3, or m, that would be 7 minus 3, which is m to the 4th. So I'm going to put m to the 4th on top. Now you could leave that 1 there if you want. I just sneakily changed it into m. Here, this becomes n to the 2 minus 4, which is n to the negative 2. So it's going to be n squared. And so our answer is m to the 4th, all divided by 6n squared. Now we're taking a look at question number 8. Now the first thing I do is I look inside. Is there anything inside this radical? For those of you that don't know, the radical means the square root. Is there anything inside that square root that I can simplify? Will something divide into 12 and 121? And the answer is no. So then what I'm going to do is I'm going to separate it out. So I have the square root of 12 on bottom and the square root of 121 on top. I'm sorry, I said that backwards. Square root of 12 on top and square root of 121 on bottom in the denominator. I'm going to take 12 and factor it. That's 4 and 3, which is 2 and 2. So I know this becomes 2 times 2 times 3 in the numerator. And in the denominator, I have the square root of 11 times 11, because this is a perfect square, which is 11 times 11. It's a square root, which means I bring it out in groups of 2. I've got a 2 that comes out. So in the numerator, I have 2 square root of 3. And in the denominator, I have 11. It comes out, and I just have 11. I have 2 groups of 11. That's horribly written. Let me rewrite that. So my final answer is 2 square root of 3, all divided by 11. There's nothing else I can simplify. There's nothing that will divide into 2 and 11. So we're done. Well, you guys are just going to have to deal with that. All right, we're taking a look at problem number 9. Number 9 is trying to test whether or not you understand when to add the radicals or not. So when I look at this, the first thing I notice is that this is a 1 in front. I also notice that I have 2 that are square roots of 2 and 2 that are square roots of 5. Now, when I was teaching this to my kids, I told them to think of it like this. If I had written a question like this with the y's and the x's, would you have put 2, 6, 4, and 1 all together to give me any answer? The answer is no. You would have done like terms. So you would have said negative 10x plus 3y. And so you're going to do the same concept here, only this time we have the radical in the problem. So I notice that I have 2 and 1. That gives me 3 square root of 2. Negative 6 minus 4 is negative 10 square root of 5. And we're finished. And that's problem number 9. Problem number 10, we need to simplify. So I'm going to do a factor tree for 128. Now you could do your factor tree different, but I tend to look for square roots. For perfect squares. So what that means is I'm looking for 25, 64, and things like that and trying to figure out how to get to it. It doesn't matter if you use that or not. When you're done, you'll still end up with the same thing. So the square root of 128 becomes the square root of 2 times 8 times 8. So I'm going to bring an 8 out, and this problem becomes 8 square root of 2 plus, I'm going to take a look at the 50. Square root of 50 becomes the square root of 2 times 5 times 5. All I'm doing is pulling that from the factor tree up here. I've got a group of 2 bring it out, so this becomes 5 square root of 2 plus 5 square root of 2. So all I did was simplify and replaced the problem. Now these have like radicals, which means I can add them. So then 8 plus 5 is going to be 13 square root of 2. All right, now I've finished problems 1 through 10 on your final exam review. The next video should have 11 through 19. If you need to see the other ones, keep watching. And remember, your review is worth 10 points on your final exam.